I'm Dr. T. Welcome to my office. So today I've got a rather interesting personal story. Okay, a rather amusing personal story, but does highlight a meaningful difference or something we need to look out when we are talking and reading scientific literature. So back when I first started teaching, I had a biochemistry lab going on. I was using this piece of equipment, and I got this note that I didn't understand what it meant, and later I would find out what it meant. What turned out the student had done, this was a student working with a piece of shared equipment that I was about ready to use, and he was letting me know I couldn't use it, although I didn't quite understand that, because he had taken the computer and instead of plugging it into the equipment that was normally plugged into, it was plugged into a pH probe in a cold room. And a cold room is just a walk-in refrigerator. So I get to the computer, I set up the equipment, and I start it, and instead of displaying what I think it's displaying, it's actually displaying the readout from that pH probe. And of course, it's in a raw voltage, so I don't recognize its pH. And it's this bizarre sawtooth pattern. And it's just up, down, up, down, up, down. And I'm like, what on earth is going on? It doesn't click to me what that note meant at this time. It's only later like, oh, that's what happened. And so I was like, okay, what's going on? So later on, after I figure out that that was not doing what I thought it was doing, it was in reality connected to that pH probe, the sawtooth pattern became obvious. It's sitting in what is effectively a walk-in refrigerator. Now, refrigerators don't have their compressors running all the time. They have a thermostat, and once it warms up enough, that it kicks on the compressor, and it cools down the room or the refrigerator, and then it turns off. And then the insulation keeps the heat out, but only so much, and then it warms back up. And then the compressor kicks on, and it cools the room down. Well, that sawtooth pattern was looking at the small change of pH that occurs when temperatures change. So the temperature in that room over the course of 15 minutes or so was fluctuating. It was fluctuating probably only by maybe a degree, possibly less than a degree. And as such, the solution that the pH probe was in was fluctuating by a few hundredths of a pH unit. Just enough, though, for me to see this bizarre sawtooth pattern coming out with a computer that was monitoring the pH. Now, this is what we would call significant. I can see the sawtooth pattern. I can see this kicking on and cooling off pattern through the through the pH that's fluctuating due to the temperature fluctuations. But is it meaningful? No. We're talking keeping a temperature within probably a degree Celsius, probably even less than a degree Celsius. And we're talking a pH swing of a few hundredths of a pH unit. Maybe a little bit more. Not much. Anything I'm doing, this isn't going to affect me. It's just interesting that I can see it. So when we see a scientific paper use the word significant, that word comes from the statistics, comes from the math folks, meaning that we are certain that there is a difference. We can tell that these two different things are different. The instrument that the student had set up was able to tell the difference in the pH between when the compressor in the cold room had kicked on and cooled it down and when it had turned off and the room had warmed up by a tiny amount. Now, was that change enough for anyone to care about? No. It wasn't meaningful. So we do have to be careful. Whenever we see the word significant, it does not translate into meaningful. Yes, there may be a difference, but it may not be big enough to care. It's just big enough to see. So with that said, have a wonderful day.